viewers, welcome to another episode with Excellence Tuition Center. Today we are going to be revising section C of Combined Science Specimen Paper 2. Before I begin, I want to remind you to like, share and subscribe. So section C, the instruction reads, answer any two questions. Write your answers in the spaces provided on the question paper. So question 10, so we are going to answer all questions for the sake of revision. So question 10, it reads, table 10.1 shows the effect of three substances, A, B, and C on universal indicator solution. So this is the table, and we have substance A, which is red, substance B, which is green, substance C is purple when mixed with universal indicator solution. Item 1, state the function of the universal indicator solution. So the function of the universal indicator solution is to test for the pH of the solution. So the universal indicator solution is used to test for the pH of the solution. Item 2, deduce the nature of substances B and C. So substance B, it is green in universal indicator solution. So green, it stands for neutral. So green, the nature of substance B is a neutral substance. So it is a neutral substance. And then C, it is purple in color. So C, it is an alkaline substance. So this is an alkaline substance. Part B, diluted hydrochloric acid is reacted with magnesium carbonate. State the type of reaction. So the type of reaction between hydrochloric acid and magnesium carbonate is a displacement reaction. So the reason why it is a displacement reaction is because magnesium displaces hydrogen in hydrogen chloride or in hydrochloric acid. Item 2, write a word equation for the reaction. So the equation is magnesium carbonate plus hydrochloric acid. Hydrochloric acid, it gives magnesium chloride plus carbon dioxide plus water. So this is the word equation, and I can even write the chemical equation. So magnesium carbonate, the formula is MgCO3 plus 2 moles of hydrochloric acid forming magnesium chloride plus carbon dioxide plus H2O, which is water. So these two here is to balance the equation such that here we have 2 hydrogen atoms, we have 2 on the right side, we have 2 chlorine, and here we have 2 again hydrogen, we have 1 here, magnesium we have 1 magnesium here, and then another magnesium here. Carbons we have 1 here, 1 here, then oxygens we have 3, and then here 2 plus 1, which is 3. So when you are checking if the equation is balanced, you check the atom or the elements one by one. So that is the word equation and our chemical equation. So you need to ensure that it is a practice that you need to have to ensure that the equation fits in one line, both the word equation or the chemical equation. Question 10, it reads, chemical equations for 2 redox reactions are given below. define oxidation in terms of oxygen to electron transfer. So in terms of oxygen, oxidation is gain or addition of oxygen. And in terms of electron transfer, oxidation is loss of electrons. So oxidation and reduction can be defined in terms of oxygen, hydrogen, electrons, and in terms of oxidation state. So in terms of oxygen, oxidation is gain of oxygen, whilst reduction is loss of oxygen. Oxidation is loss of hydrogen, whilst reduction is gain of hydrogen. Oxidation is also loss of electrons, but hydrogen is gain of electrons. Oxidation is increase in oxidation state or oxidation number, but reduction is decrease in oxidation state or oxidation number. So we can define reduction and oxidation using in 4 ways, which is in terms of oxygen, in terms of hydrogen, in terms of electrons, or in terms of the oxidation state or the oxidation number. And item 2, it reads, state what happens in terms of oxidation and reduction to iron 2 chloride FeCl2 and copper 2 oxide CuO in the 2 redox reactions. So iron 2 chloride, from this reaction, it has been oxidized. So the reason why it has been oxidized is because it has changed from Fe2 plus, which is in iron 2 chloride, to Fe3 plus in iron 3 chloride. So you can see here that the charge has increased, meaning say that the oxidation number here, it was +2, here is now +3. It has also increased. So it means that iron has been oxidized. So iron 2 chloride has been oxidized to iron 3 chloride. And copper 2 oxide. So copper 2 oxide has been reduced. Why? It is because it has lost an oxygen atom. Here it was CuO plus. Here it was CuO, and now it is Cu after the reaction. So the oxygen atom has been removed from copper, so it has been reduced. So it has lost an oxygen atom. Question 11, it reads, Fig 11.1 shows the blast furnace used for the extraction of iron. So this is the diagram for the blast furnace. Here we have molten slag and here we have molten iron. Item 1, it reads, name the substance that enters the furnace through S. So the substance that enters the furnace through S. So here you just need to study the openings, how the openings are arranged. So you need to memorize the openings of the blast furnace. So S here, it is the opening where hot air blast enters into the blast furnace. So the hot air blast enters through opening S. Item 2, state what is released through ARA. So through ARA, it is the hot waste gases. So here through ARA, the hot waste gases are released. Question 11b, item 1, it reads, describe the main reaction which occur in the blast furnace. So you need to describe the main reactions which occur in the blast furnace. So there are about 5 of them. So the first reaction is that coke reacts with oxygen in the air, because we have our hot air blast, so it contains different gases, but the reactive gas in the air is oxygen. The second equation, carbon dioxide is reduced to carbon monoxide as it rises in the furnace. So the carbon dioxide reacts with more coke. So carbon dioxide plus coke, it forms carbon monoxide. The chemical equation, it's CO2 plus C to form 2CO. Reaction 3, the carbon monoxide reduces iron 3 oxide to liquid iron. So iron 3 oxide plus carbon monoxide it forms iron plus carbon monoxide. Reaction 4, the calcium carbonate decomposes to form calcium oxide. So because of the high temperatures in the blast furnace, the calcium carbonate, which is placed, or the limestone which is placed amongst the raw materials, it decomposes, or it breaks down to form calcium oxide and oxygen and carbon dioxide in the presence of heat. So it's calcium carbonate to form calcium oxide plus carbon dioxide. And the chemical equation, that is CaCO3 to form CaO plus CO2. Reaction 5, the impurities which are present in the blast furnace, they react with calcium oxide to form slag. So the equation is calcium oxide plus silicon dioxide. It forms calcium silicate, which is the slag. So the chemical equation is CaO plus SiO2 to form CaSiO3. So because slag is lighter, or it is less dense than iron, it floats on iron and is also drained out as a liquid. Question B, it reads, explain the advantages of having slag covering the molten iron. So the advantages of having the slag covering the molten iron is that it prevents the iron from further reactions. So the slag acts as a layer of protection. Part C, a sample of iron oxide was found to contain 70% iron. Find the empirical formula of the iron oxide. So you are given 70% of iron, and it is a sample of iron oxide, so it means the rest is oxygen. So if you have 70% of iron, it means you have 30% of oxygen. In terms of mass, you can just directly convert the percentage to masses. So it is 70 grams of iron and 30 grams of oxygen. And then we can form a table. So what we have to calculate first is the number of moles of each. So you calculate the number of moles of iron, which is 70 divided by 56, you get 1,25 moles. For oxygen, 30 divided by 16, which is 1,875. And then the next stage, divide by the smallest. So divide 1,25 both sides. 1,25 divided by 1,25 is 1. And 1,875 divided by 1,25 is 1,5. And then the ratio, you multiply both sides by 2. So here we do not round off. If you can have a multiplier which gives us exact values. So 1 times 2, we get 2. 1,5 times 2, we get 3. So therefore the empirical formula is Fe2O3. Question 12. The flowchart in Fig 12.1 shows stages in the manufacture of sulfuric acid. So stage 1 is the production of sulfur dioxide, and it moves to stage 2 where it is combined with oxygen. The sulfur dioxide from stage 1 is combined with oxygen in stage 2 to form sulfur trioxide. Then our sulfur trioxide from stage 2 is combined with substance X to form oleum in stage 3. Stage 4, our oleum, which has been formed from stage 3, is combined with water to form a certain product, which is our sulfuric acid in stage 4. Item 1, it reads, name the industrial process that produces sulfuric acid. So the process is called the contact process. Item 2, describe the production of sulfur dioxide in stage 1. So in stage 1, the sulfur is oxidized to sulfur dioxide by burning sulfur in air, or it can be produced by strongly heating the iron sulfide ores in air. Item 3, state 3 conditions required in stage 2. So the conditions required in stage 2, we need a temperature of 450 to 500 degrees Celsius, 1 atmosphere of pressure, and vanadium pentoxide catalyst. Item 4, it reads, explain why stage 3 is necessary. So stage 3 is when we react sulfur trioxide with less concentrated sulfuric acid so that we prevent the formation of an uncontrollable fog or a mist of sulfuric acid, which is difficult to condense. Item 5, name the substance X. So the substance X, which we combine with sulfur trioxide from stage 2 to form oleum, is concentrated sulfuric acid. So 12A, item 6, write an equation for the process occurring in stage 4. So here the equation, the word equation is oleum plus water to form sulfuric acid. So if the question is not really specific, whether you need a word equation or you should write a chemical equation, you can just write a word equation so that you avoid complex formulas. So the chemical equation is H2S2O7, which is oleum, plus water, H2O, to form 2H2SO4, which is sulfuric acid. State any two uses of sulfuric acid. That is question B. So it is used for making plastics, paints, dyes, insecticides, fungicides, artificial silk, soaps, and detergents. It is also used in refining of petroleum. It is also used in electroplating and galvanizing to clean metals before the coating process. Well, ladies and gentlemen, we've reached the end of section C. Don't forget to subscribe, like, and share. Thank you for watching.